Welcome to this segment of the American Physiological Society Living History Program. Today we will have a discussion with Professor Abba Kastin, MD, about his career, accomplishments, and where it all started. My name is Claude Bouchard, and I am the John W. Barton Chair in Genetics and Nutrition at Pennington Biomedical Research Center. Dr. Kastin at the center as an endowed chair, and is the director of the Blood-Brain Barrier Laboratory. So in the next 45 minutes or so, we will explore his education, scientific contributions, and the activities of the past and ongoing projects that he's still pursuing, even though he's past the retirement age. So Dr. Kastin, welcome to the program.
A pleasure to be here, Dr. Bouchard.
Okay. So how about first tell us about your family upbringing and the kinds of things that perhaps put you on the road to science.
Actually, I can't think of any direct action or that I had during my upbringing that would lead me to science. Indirectly, there may be some. My father was born to Poland, came here at a very young age on his own. My mother was born in this country, and throughout my upbringing, my father, who's a businessman, never encouraged me to go into science, and in fact, never encouraged me to do anything. Unlike this popular tiger mom now who made their kids take music lessons and do a musical instrument, my dad never even told me to study, never talked about the old country. And when I did take up violin, it was because a junior high orchestra came to our elementary school and they played some separate instruments, and I thought, oh, violin's very pretty. I asked my dad if I could take that up, and he said yes. So it was all nothing direct. However, there were some indirect influences, I think, and a lot of that had to do with both my parents being Jewish. And as I say, I'm extrapolating a little on this, but I think one grows up a little different in the sense, well, my name's different, I'm taller than most people, but if all your neighbors and friends and classmates seem to be Christian and you're not, it just leads you to question things. So I think indirectly that questioning attitude may have had something to do with it. But in terms of directly going into science, never was mentioned.
But you did. So can you tell us about what happened during your undergraduate and graduate studies that eventually led to a career in science?
Actually, it probably didn't start to postgrad, but if I can start even earlier to elucidate, just to at least mention some of the factors. So I'll start in elementary school.
Okay.
In third grade, the teacher apparently thought I was a little bored, maybe restless, asked me if I was bored. I thought about it and didn't think I was. But at any rate, she had me tested, so I skipped a semester in fourth grade. And then in fifth grade, I remember being the object of some ridicule in the class because the teacher in a commendatory way would ask questions, our opinions about different matters. And it seemed that my opinion was always different from everyone else in the class. And in fact, I remember even one time she just called me in front. Why couldn't I be like, and named two people in the class, one of whom became a salesman, the other one didn't go on to college. But I mean, that wasn't important. It was just Apparently, I had my own opinion, or maybe I liked being a little bit different. I'm not sure. So I wasn't very popular in 5th grade. But at the beginning of 6th grade, we took the Iowa State reading test. And I scored at college or post-college level. And all of a sudden, the teachers loved me. And even at that young age, I thought, this is a little hypocritical. I mean, I knew darn well why they had changed their opinion. But I forgot. Between 5th and 6th grade, there is something that influenced me on the road to going to science, but not science. My mother died. So it's difficult to know, how much of an influence that had, but maybe it predisposed me to medicine, but again, not science. And then we had junior high school, 7th, 8th, 9th grade. I was on the newspaper, nothing much there. And then in 10th grade comes another factor. So the teacher asked me what language I was going to study. And my dad spoke a little French, so I said French. She said, "You're not going to study French." Okay, how about Spanish? "No, I don't think you should study Spanish." Okay, what am I going to study? Latin. Okay, Miss Ryan, why am I going to study Latin? Because you're going to be a doctor. So apparently, getting back to doing well on this Iowa State reading test, and I guess I was getting decent grades, I think it was just an assumption that in those days, smart people become physicians. I can't say that I believe that, but at any rate, that was pretty much it. So then comes 12th grade, the end of high school in the States. And now these dates I'm going to tell you are approximate, but you're going to have a hard time believing my naivete. So I get called down to the vocational guidance officer, whose name was Miss Witsey. And let's say it was around Thanksgiving. And she said, "Where have you applied to college?" I said, "I thought you applied to college after you finish high school." In this day and age where people take their newborn kids and register them for pre-K and special schools and private schools, it's difficult, I'm sure, for anyone to believe that I was that naive. I mean, not only didn't I know what I wanted to do with my life, but I had no idea of the timetable. And then to reinforce it, she called me down, and I remember asking her where I should apply, and she was a little hesitant. And I said, well, I was the first one in my high school, in the history of my high school class. My class was about 400 to get straight A's, never get a B. So I asked her what's the best school, and she reluctantly told me Harvard. So then she calls me down Christmas time and said, "Where'd you apply?" And I told her Harvard. And I remember how distressed she was, where else? And I said, "Well, that's the only one we discussed." And she, even now, I can't believe how naive it was. And she couldn't either. So by that time, it's getting a little late. So I apply a couple other places. And to show you how late it was, I got an application from Barnard, which is the Women's School of Columbia. And by the time I sent it back, they realized that Abba is a male name, so they allowed me to apply late. So it was that much of a deadline. So I went to Harvard and thought I'd be a physician because Miss Ryan thought that's what people who tested well did. And so I took pre-med courses, but I had an influence. I majored in biochemical sciences, but I didn't go out for honors. And which meant I wasn't eligible for Phi Beta Kappa, and which otherwise I would have been eligible for. And subsequent years, they made it that if if your grades were, I don't know, as high as mine were in biochemical chemistry, you were required to go up for honors. So by not doing it, though, I was able to take the last 2 years all of these courses I loved: art, music, economics for the idiot, astronomy for the idiot. Those were the nicknames of these courses. American novel, poetry with I.A. Richards, all of these really great courses. And in college, I pretty much skipped as many labs as I could. I thought labs were so boring. Why do an experiment that you know what the answer is going to be? It just didn't make any sense. I mean, it was just make-do work. And I was busy. I mean, I was on the varsity swimming team. Freshman year, we had different freshmen year. I did swimming and crew. But the varsity crew coach told me I wasn't good enough to do both. So I stuck with swimming, and we were, not thanks to me, but our team was top 10 in the country all 4 years. And then I played in the orchestra. That was 2 nights a week. And the rest of the time I was studying, and labs were just sort of a waste of time to me. I could have been learning something and studying. So, at any rate, I applied to Harvard Med School, which most Harvard undergrad pre-meds did. I had one of the early interviews. And to get back to your initial question of how I got into science, I think this one will surprise you. Since I had an early interview, when I came back, many of the pre-meds came to see me to see what questions I was asked so they could be prepared. And the only question I remember, because of the reaction I got, was, or not question, I just remember telling whoever interviewed me that I knew Harvard Medical School turned out lots of researchers, and I had no intention whatsoever of going into research. And this guy said, well, you can forget about getting into Harvard Med. And of course I remembered because I did and he didn't. That answers your question. So it wasn't like many scientists who start out their life and, oh boy, I can't wait to do science. So I thought med school was kind of boring too, because it was just, I'm exaggerating, but in those days we had lots of lectures. There was a lot of stuff to memorize and learn. Getting back to sort of being a little different, I was thinking, well, endocrinology sounds different. I didn't know anyone who went into it, and it was kind of an open field, and I was fascinated that these little hormones could go all over the body and influence the whole body. So I hung around a little bit in an endocrine lab run by Don Nelson under the auspices of George Thorne, who was head of medicine. And mainly I just did adrenalectomies. It was kind of like being in a lab, didn't stimulate me too much. The question that being asked I can't even remember, so I guess it didn't have much of an influence. And then I went to do my internship. And now we're getting into how I think I kind of fell into science, which has given me a life that more pleasurable than I could ever have imagined. At any rate, so I'm doing an internship at a place with a really good clinical, well, the top clinical endocrinologist at the time. And although there were no wars going on, they were drafting doctors. The draft was on, there was a doctor shortage. And there were people in their internship, you could have 10 months through your internship, be drafted, and when you come back, no one's going to take you for 2 months. It's like you start over. And I don't know how. I heard about this deal at NIH called the Clinical Associate Program. And what you do, you apply during your internship, first year post-grad after med school, And if you're accepted, then you get a public health service appointment. And the way the law read, if you served in a uniformed service that met your apparently military requirement, to get ahead of the story, none of us ever had a uniform in the public health service. And I was interviewed at endocrine branch of the Cancer Institute by Roy Hertz, who later won the Lasker Award for something unrelated to whatever I got into. And apparently he liked me. It was certainly the most competitive thing I ever did. I mean, more so than getting into Harvard College or Harvard Med School, because they only took 30, 35 people, and it was very undemocratic. So first, they deferred you through the rest of your internship and a year of residency. Then you went there and accounted for residency, fellowship, and you started your research. And they later abolished it because it didn't seem fair that this should happen. And by the way, Brown and Goldstein had an editorial, maybe, I wish I could remember, 4 years ago in Science, the first editorial about this program and how much good it had done, how many nice people, good researchers they had turned out. So anyway, I get there, and there was only three of us in this little branch that year, and they put me with the sort of the newest member of the group who had been in private practice, somehow decided he wanted to do research, came back. And he said, what do you want to work on? I said, I don't know. I mean, just like I never knew I was going into science. I mean, I'm not sure my motivation was the best for getting into this program. But he encouraged me to, well, what are you interested in? Well, I've always been interested in the relationship, how the body and the mind and the body are connected, how the brain controls the rest of the body. It was sort of endocrine related. Psychiatry and neurology certainly didn't appeal to me. And he said, well, go to the library and come up with a brain-body project. So somehow I found out that Geoffrey Harris in England was working on how one of the primitive parts of the brain, the hypothalamus, controlled the pituitary. It was very theoretical. And I thought, this is really interesting. And then I looked a little more, and there were already groups working on how the hypothalamus controlled every pituitary hormone, but there was one pituitary hormone no one in the world was working on in terms of hypothalamic control. And that was MSH, melanocyte stimulating hormone, that enables frogs to change color, camouflage. And the melanocytes are of neural crest origin. So even though MSH, at least at that time, didn't seem to have any role in mammals, I thought there'd been some work in frogs that this would be an area of interest. And then I got hooked. And that's how I got into science, very indirectly. I mean, it was a good thing that I tested well. I wouldn't have gotten it at NIH. It's a good thing I liked being different. I wouldn't have started work with MSH. It's a good thing I can question things, or I don't accept dogma, because this hypothalamic hypothesis at that time was, very few people believed it. Now let me just make one last thing. How did I get to New Orleans? Would you like to hear that now or later?
So why don't we do that? Tell us about your connection with New Orleans and Louisiana in general.
Well, I think this may surprise you also. I was tricked into coming to New Orleans. So normally this NIH positions, sometimes called yellow berets, last 2 years. But my research was going pretty well. They let me stay on a few extra months. And they said, well, what are you going to do when you leave here? You know, it's somewhat like high school. I mean, I hadn't given it much thought. But I just started an interest which has now blossomed, and that is world travel, particularly liking going to different places before they change. I've been to more than 100 countries, a dozen Muslim ones, because they're very interesting. So I said, I want to go to Europe and do a postdoc. And they said, well, there's no one in Europe other than Jeffrey Harris doing anything related to hypothalamic control of pituitary function, or MSH, and I'll work on it. So I found a place in Sweden, in Gothenburg, that was working on hypothalamic control of temperature in goats. A little bit lateral from what I was doing. And I applied. And I had told you this was a very selective group. So I applied they accepted me for an NIH postdoc. I was turned down. No clinical associate had ever been turned down for a postdoc from NIH, because as I said, it was a selective group. And in the meantime, they had been wanting me to come down to work with someone they said was a chemist in New Orleans working on the hypothalamic control of pituitary function. I told them, I said, I majored in biochemistry. They said, no, a real chemist. So I had already talked to him, and I wasn't that anxious to come down here. And when I got turned down for my Swedish postdoc, I came down and I worked in Andrew Shalley's laboratory. And fortunately, I was his first postdoc. Fortunately, he needed me. I needed him to purify these hypothalamic substances. And it was only maybe, about a dozen years later, after he won the Nobel Prize, that Mort Lipset, one of my mentors at NIH, told me that he and Griff Ross, who was the person who told me to go into the library and search, that they had, he didn't use the word, but basically they had sabotaged my Swedish postdoc application for my own good. And was I upset? And although some people I felt I should be, I wasn't, obviously. But there's a coda to this story. When about maybe 4 or 5 years ago, when I received an honorary doctorate from Uppsala University, I told, basically, in one of the lectures, I told a version of this story, and the professor from Gothenburg had since subsequently moved to Uppsala. Unfortunately, he was ill that day, but I'm sure they relayed the story to him.
He knows now.
I think so.
So this brings us back to the science, and you've been active in research for a while, highly focused. Tell us about your contributions. What you think are your most important contributions to neuroscience, endocrinology in general?
So just as the Nobel Prize was given for the isolation of peptides from the hypothalamus that controlled pituitary function, it occurred to me, as someone who believes in the efficiency of the body, usually, that these hypothalamic peptides, instead of working just down on the pituitary, might work up on the brain. And so we tested the effects of peripherally administered MSH on the brain. Most people in the field, almost everyone I could think of, thought that any peripherally administered peptide could not possibly influence the brain. Forget about how it would do it, it just couldn't have any effect at all. So with Kurt Salmon and Lyle Miller and Rudy Aronson, we did that. And then people gradually began to accept that. David DeWeet's group was active also in that. And then the focus was, well, how can this happen? And that's when we had the idea that they could cross, the simplest idea would be to cross the blood-brain barrier directly. But that was, again, dogma. Peptides don't cross the blood-brain barrier. So with Bill Banks and some other people, we devised a more sensitive method and showed that peptides can indeed cross the blood-brain barrier. And that is maybe one of the concepts that we introduced against published statements that they can't cross, that perhaps was the most influential. And related to that are some other concepts. So peptides are rapidly broken down in blood. So we showed that there is really no correlation with the short half-life in blood with a more prolonged effects in the brain. We also showed that the peptides, the effect need not be linear, can be a, we call inverted U-shaped curve. This was best illustrated with one of our compounds, MIF1, that we took from the lab to the clinic with Rudolf Erickson in studies of depression. A little bit acted very early in depression, but if you gave too much, you lost the effect. It wasn't negative, it just lost the effect. So it needs not be linear. And then related to that, we showed that the name of a peptide need not be its only action. It was amazing how many young scientists thought, well, if this is melanocyte-stimulating hormone release inhibiting factor, it only affects MSH, or growth hormone only affects growth, but we showed that, I mean, it seems commonplace now, but you can't believe the confusion. So that first, that a peptide can have more than one action, because it was thought one peptide, one action. And then that the name, could be more encompassing than that. So there was that whole aspect of our work, and then related to these prolonged effects with a short half-life, we showed you could give it perinatally, either during gestation or a newborn, and have effects that persisted to, or sometimes weren't even manifested until adulthood. And then another aspect involved, related, but involved our work with opioids, which we did with the Olsons, again with Erickson, and we found just that there is a very high affinity mu opioid receptor selective peptide that exists in the brain called endomorphin. And our discovery of this has been cited more than almost 1,000 times. And then we also showed that just as the brain makes opiates, it can make anti-opiates. So there's endogenous anti-opiate substances. And then probably the most recent concept we've been working on with Dr. Wei-Hong Pan, who also contributed greatly with blood-brain barrier, not just of peptides, but with polypeptides, cytokines, and chemokines. But now we're focusing more on the role of astrocytes. They assume an active role in response to metabolic changes like obesity, and particularly involving leptin. So there were some other things we did, but that kind of encapsulates, I think, my main contributions to science with these wonderful, but very few people, collaborators.
So over the last 10 years, you have moved your laboratory and operation here at the Pennington Biomedical Research Center.
That you did so much to build.
Well, that's another issue. My question to you is, what is now keeping you busy? What are the questions that you're pursuing?
I'm still interested in how the mind, how the brain and body communicate. And astrocytes are actually involved, and their end feet are involved in the blood-brain barrier. And we're now, with others, showing astrocytes are no longer just supporting cells in the brain. They interact directly with neurons, influence them. So there's that influence, and then with Wei Hong's interest in sleep, we're relating them, and recently published something, a paper in Journal of Neuroscience, how sleep affects blood-brain transport and function. So it's just this same, it's almost as if this isn't the way it works, but one could make the case that by getting into science, having my interest so late that it's just postponed it, so I'm still fascinated by all that needs to be done.
I'm sure there are there are other explanations for that too. Other potential explanations for that. So, Abba, besides your deep involvement into the lab and scientific questions, you have also been very engaged in promoting and leading efforts that can be seen as supportive of science in general, in the publication field and the organizational field in science. Can you tell us about these other activities that have been part of your career?
Sure. Basically, I'll start with a journal. And I was reminded of this. It turns out, so I've been I just finished 35 years of being editor of science, of peptides, the international journal. And they're putting out a Festschrift in my honor this year. And one of the contributors was present when I first accepted the job as editor. And in his article, he reminds me that I was very reluctant, because I thought being an editor is something you do when you're done doing research. But what took me to it, attracted me to it, was the fact that there were so many different aspects of peptides and the people there that all had their own little, I'll call them clubs, but they're not really. So there was invertebrate peptide people and amphibian skin peptide people, or even some plant peptide people. So I thought by being editor of a journal, I wouldn't stick with some editors do with just their own field of interest. I would try to have it all encompassing. And that's what I try to do in my 35 years as editor, and also in the 2 editions of the Handbook of Biologically Active Peptides, where we have 21 sections: plant peptides, invertebrate peptides, venom peptides, to try to bring it all together. Our 2nd edition has 2,000 pages, 260 chapters. And then this led me to, as the peptide field started exploding, everyone wanted to form their own society. So Fleur Strand and some other people, Kurt Salmon and others, got together and asked me if I could have sort of an umbrella peptide society, which is now called the International Neuropeptide Society / Society for Biologically Active Peptides, that would have smaller meetings. And I've been saving this to show you. So unlike most people who like going to these huge meetings, in this Scientist, 1992, quotes me as saying, Abba Kastin, he no longer attends large meetings with multiple themes. So even though in the article I discussed the pros and cons of the various meetings. Once they said I no longer go here, I felt obligated to fulfill this prophecy. And so that's why our society, and I've been favoring smaller APS meetings, although I used to go to, the large FACEP meetings. And the sort of humorous story is at large meetings, now Society of Neuroscience is over 30,000, endocrines, anyhow, they're all huge. It's hard to really meet anyone. And the kind of joke goes around about what they call conventionize. So here you are talking to someone, but that person is looking around to see if there's someone, quote, more important that he can dash off and see, because at a large meeting, you only get one chance to see someone like that. Whereas a small meeting, there's not this urgency and you get to meet lots of people.
Very interesting. I'm sure many people can empathize with that. So you've been a member of the American Physiological Society for several decades. You've participated in some of their meetings, you have been publishing in their journals, you've been a leading neuroscientist, you've made many contributions to the blood-brain barriers. You know what is the enterprise of science. What advice would you have for the young people today who might be contemplating a career in science?
This is the most difficult question you asked me. The question I used to be asked by young people after college, should I get an MD or PhD? I thought my MD degree was a waste, although it is a good union card to have. But it helped me because I knew that I didn't learn anything very well. In fact, to exaggerate not much, I can't think of anything I learned in med school that's really helped me in my research, any facts. But could be I'm overstating. So my tendency in those days was to encourage young people to get a PhD, although the danger there is they only learn one area and they feel they're going to stick with that the rest of my life. I felt I didn't know anything. If I asked a question, I knew I didn't know anything. I'd find someone who knew the answer, or I'd have to find it myself. It wasn't that I had any preconceived ideas. But that's not even the question. Now the question is, that you're asking is, what advice to someone who wants to go into research, regardless if they have an MD or PhD degree? In this day and age of abysmal research funding, political and politically correct encroachment out of different rules and regulations, I really don't have an answer. My life, I can't imagine a better life. If I had expectations, they've certainly been exceeded. But it's certainly much less fun now. So I hope that people say, well, there's ups and downs, and if there's going to be an up, then there's up in research funding and interest, then indeed I can't imagine a better career. But if it's going to continue the way it is, I don't know what I would tell someone.
Although what you just used as a preamble to this response was that if you hyper-specialize too early, you lack the broad base that allows you to see things, connect things, think in broader terms, and that may be a limitation over the years if you pursue a career in science. But your last point is well taken. There's a paradigm shift that's needed for the environment to be pro-science again.
Yeah, sooner the better.
The sooner the better. On this we agree. And we're going to first thank you for your contribution today, Dr. Kastin. On behalf of the American Physiological Society, we're very pleased that you have agreed to be interviewed for the Living History Project. And thanks for listening.
Thank you.